Okay, so today we are going to tackle problem number 7 from Project Euler, 10,001st prime number. So in order to do that, we're going to open a new VI. And I'm going to save this as problem 7. It is 10,000 prime number. 10,001st prime. Okay, so the first thing we'll do is take a snip of this so we can have it available to look at. And start from here. So actually something I want to do is modify the project. I'm going to add a folder auto-populating. What this allows me to do is to add a separate folder of VIs that then takes all of the VIs or any files in my file structure and organizes them automatically. You can see here I have this organized. There's this Project Euler, and I have all of my problems set up in this folder. By adding this folder auto-populating, it automatically takes whatever's in this folder and organizes it in LabVIEW. I'm going to do the same thing with the subVIs folder because I am going to use this check for prime number VI. Another thing that I already know I need to do, I have it automatically selected here that 1 and 2 is a prime number, and I overlooked this. 2 is actually a prime number, but 1 is not. So I'm going to duplicate this case for the 1 and make sure that 1 is always a prime number. So 1 is not a prime number, 2 is a prime number, and then for the rest of them I need to do this. I'm also going to rearrange these cases, sort by that, and then save it. Okay, so now I'm going to go back here to my actual problem 7. Get the block diagram up here. Okay, so the thing that we need to do to this, we're going to use this check for prime number, and we're just going to plug this number into here. I don't know how high this is going to go. So again, I've said this before. If the number goes above 2.1 billion, then this number is going to roll over, or I don't know, maybe it saturates or something in a while loop. And so we'll run this once and see how high we get. If we need to get something bigger than, if we end up, if the 10,001st prime number is something larger than 2.147 billion, then we'll handle that there. So the next thing that we need to do, we need to keep track of how many prime numbers we have already found. And so in order to do that, I'm going to create this number here, and I'm going to pass it in a for loop with a shift register, and I'm going to use this select function to decide whether or not I will increment this number. So this is kind of a nice trick. Oops, it needs to go on the select. Sorry. This is a nice trick for keeping track of counting things that happen on an indeterminate basis. So you're not sure how many loop iterations are going to take between counter iterations, and so all you have to do is just pass your shift registered number into this +1, and you keep track of it like this. If your number you're looking at is prime, then you pass the incremented number into it. So the number that comes out of this select is the incremented number. If it's not prime, then you pass the false into this, and then just passes the output of this select into, the shift register. So now if the number is prime, the incremented version will go through. So this will go from 0 to 1 to 2 to 3. And if it is not prime, then the false version will go through, which is just the same as the last number that was put into the shift register. So the last thing I need to do, I'm going to put some indicators here. Create an indicator, current number to check. And I'm also going to put one here, create indicator. I'm going to call this prime number count. And this will show us, this will give us some kind of visual indication while the VI is running what number we're currently on and how many numbers we have found so far. So the last thing that I want to do is stop this VI once the current prime number, create a constant, or once we found the 10,001st prime number. So I think we should be able to just watch this. We're going to run this here right now and see what happens. Okay, so this says the 10,001st prime number is 104,743. So let's go look at our solutions guide. This is problem number 7, and the 10,001st prime number is 104,743. So again, like always, I'm going to assume that this is right, and so we've got the same answer, and so that's it. The solution to problem number 7 in Project Euler in LabVIEW. See you next time.